Welcome back, everybody. In the last section, I showed you that logs can be interpreted as exponents and vice versa. So let's look at a few properties of logarithms as well as exponents that we can utilize to help apply that knowledge. All right, so we're going to talk about the properties of logs and exponents. All right, so the first property of logs is called the product property, and I'm going to utilize letters to generalize the property, but we're going to do some examples to be a little bit more specific. So if I have the log of any base A of expressions m times n, that should be an n, that's going to equal the log base A of m plus the log base A of n. And there's a similar property with exponents that says the log or the x to the m power times x to the n power, same base. If you multiply, you can add your exponents. So that's x to the m plus n power. All right. So the second property is called the division property. And the division property says that if I have the log base A of u divided by w, that's the log base A of u plus, minus, the log base A of w. Now there is a similar property with exponents that says the log x to the m power over x to the n power equals x to the m minus n power. Not exactly the same, but like I said, fairly similar. All right, the third major property that we're going to use is called the power property. All right, I'm going to scroll up a little bit just to get a little more space. And the power property says the log base A of m to the r power equals r log base A of m. So you can take the power, we can bring it out front, just like we did here, and then we can multiply. And there is a power property in exponents that says x to the m raised to the n power. When you raise a power to a power, you multiply your exponents. All right, so those 6 properties are the major ones we're going to look at. There are a couple of other properties that we're going to use on occasion. As they come up, we'll talk about what they are, but I want to focus on these 6. All right, so now let's try to use some of these properties to our advantage. All right, so here's my first example. I want to express the log base A of x cubed square root of y over z squared in terms of x, y, and z. Meaning x, y, and z with no powers. This also could be written as expand to the first power of your variable. So the first thing I'm going to do is I'm going to rewrite my radical y in terms of a rational exponent, because I am using exponents, may as well write everything like an exponent. So my first step is going to be log base A of x cubed, y to the 1/2 over z squared. All right. And now I have everything in terms of exponents. The first thing I want to get rid of is I want to get rid of my denominator. Denominators sometimes will cause students trouble. So we want to eliminate that denominator. So my next step is going to be to use the quotient property, or that second law that we talked about. So to use the quotient property, basically I say the log base a of my numerator, x cubed, y to the 1/2 power, and then I'm going to subtract the log base a of z squared. All right. So after I do this, now things look a whole lot easier. So my next step, I'm going to use my my product property with my first term. My second term is going to stay the same, but that first term we can split up. So I'm going to say the log base a of x cubed plus the log base a of y to the 1/2 minus the log base a of z squared. All right, now I'm almost done. Remember, I want everything in first powers. So the last thing I'm going to do, call that step D or step 4, is I'm going to take all of my powers and I'm going to use my power property and bring them out front of my expression. So I'm going to have 3 log a of x plus 1/2 log a of y minus 2 log a of z. All right, and that's as far as I can go. All right, all we're doing is we're taking expressions and in this case, expanding them. All right, there's no equal sign, hence there is nothing to solve for in this particular problem. All right, well, just as I can expand a logarithm using my laws, I can also condense a logarithm using these same laws. So here's my next example. I can say express as a single log. All right, and I have 1/3 log base a x squared minus 1 minus log base a of y minus 4 log base a of z. All right, so my logarithm has been expanded already. So in a sense, if I were to make a comparison to the last example, this would be my answer. And basically what I would need to do is I would need to reverse my steps, and my goal is to get to that point. All right, so here's what we're going to do. So the last step I did was my power property. So in this particular example, the first step I'm going to do is my power property, because I want to bring my powers back into my expression. So I'll say step A is log base a of x squared minus 1 to the 1/3 power minus log base a of y, and then minus log base a of z to the 4th power. All right, so now you can do this in multiple steps. I'm going to make a choice, and my choice is to do a little bit of algebra. It's going to save me doing some steps with my properties of logs. But in this case, I think it's going to wind up being a little bit easier. So my second step, like I said, it's going to be a little bit of algebra. And so we are going to so the algebra is going to come in with the second part of my equation. All right, so for example, over here, all right, I have two negatives there, and what I want to do is I want to make that part a little easier. So I'm going to say the log base A of x squared minus 1 to the 1/3 power. Then I'm going to factor out a negative 1. I'm going to say minus the log base A of y plus the log base A of z to the 4th power. And what you'll see is that this is going to become much, much easier for me, because in step C, I'm going to combine what's in the parentheses. So I have the log base A of x squared minus 1 to the 1/3 power minus the log base A of y times z to the 4th. And now I can use my division property. Division property is a little bit confusing, so I want to make the division property as easy as possible. That's the only reason I did the algebra. So in step D, I have the log base A of x squared minus 1 to the 1/3 power divided by y z to the 4th. And there, my logarithm is expressed as a single log, and everything is good to go. All right, but these properties would be a little bit silly if all you did was condense or expand expressions. You have to be able to apply them to places. So the reason we have these properties is so we can apply them to logarithmic equations, which is our primary reason to apply them. All right, so let's scroll up and let's apply them to logarithmic equations. So my example is the log base 5 of 2x plus 3 equals the log base 5 of 11 plus the log base 5 of 3. Now our ultimate goal is to solve for x, right? So the directions might say solve or solve for x. All right. So now the first thing I want to do is I look at the right side and I say it's going to be very easy for me to combine that into a single log. So I'm going to keep the left side the same as the log base 5 of 2x plus 3. And I'm going to say that equals the log base 5 of 11 times 3, which is 33. So I basically used my product property. All right, so now we have a property called a one-to-one property. And basically what it's saying is if I'm applying an operation on the left and I'm applying an operation on the right and they're equal, then my variables must be equal. Very similar to, here I'll use this as scratch. If I have 2x equals 2y, right? Very easy to see that x equals y, right? But the same thing happens if I say the log base 5 of x equals the log base 5 of y, x equals y. So that's the idea behind this, all right? And if I can use my one-to-one property, what I can say is that 2x plus 3 has to equal 33 because all I'm doing beyond that is taking the log base 5 of each one of them. All right, so this is true. So now from here, it's a two-step algebra problem. I'm going to subtract 3 from both sides. I get 2x equals 30, x equals 15. I love my one-to-one property. All right, so now we need to check to make sure our solution is valid because our domain for logs doesn't necessarily include all real numbers. All right, so we have to make sure that our solution falls within the domain. All right, so we use our original question and I can say the log base 5 of 2 times 15 plus 3 log, here, let me scroll up a little bit, log of 33, right? 2 times 15 is 30, plus 3 is 33, so I have the log base 5 of 33 equals the log base 5 of 33. And that most definitely is a true statement. So x equals 15 is validated as a solution. All right, so let's try one more, because beyond that, it would just be a matter of practice and experience. So I'm going to try this one. Let's see. So I have the log of x minus the log of x minus 1, or x plus 1, excuse me, equals 3 log 4. All right. So now on the left side of my equation, I'm going to use my quotient property. On the right side of my equation, I'm going to use my power property. You don't have to do the same thing to the left and the right. We're just using a property of logs. We're not changing the value of the equation. We're just using a property to make it more pleasing. So I'm going to have the log of x over x plus 1 equals the log of 4 to the third. Now, I know 4 to the third is 64, all right? But here I have the log base 10 and the log base 10. So I can use my one-to-one property. I love my one-to-one property, and I'm left with x over x plus 1 equals 64. All right. Now from here, again, just a few steps of algebra. I'm going to multiply both sides times x plus 1. I get x equals 64 times x plus 1. Then I get to distribute. I get x equals 64x plus 64. All right. And now I'm going to subtract 64x from both sides. And I get negative 63x equals 64. And x equals 64 over negative 63. All right, so now we basically need to check our work. So we're going to go back to the original equation up here, and we're going to put in our answer and make sure that it fits our domain. All right, so I have the log of negative 64 over 63 minus the log of negative 64 over 63 plus 1 equals the log of 64, which is 4 to the third power. However, I have a problem, all right? And the problem is this, is that what's in this parenthesis and what's in this parenthesis are both less than 0, all right? And we know that the log of 0 doesn't exist, right? Because our graph winds up going like that, straight down. You can't have the log of a negative number. The argument in here can't be negative, all right? So the issue with the answer is that it's not in our domain. Hence, it's an extraneous answer. Therefore, this is not a solution. Okay, because it's not in the domain. Therefore, the final answer would be no solution. All right. So again, there's going to be a lot of practice with the properties specifically in this section. In a later section, we'll talk more about whether it is or is not a solution when we talk about logarithmic equations. But this is just a little taste of what's to come. All right, so I'm glad you enjoyed it. I definitely encourage some more practice, but thanks for listening, and I'll see you guys next time.